As I said, just talking about global mean temperatures doesn't really help because nobody lives in a global mean temperature, right? Tropics are warmer, mid-latitudes are reasonable, high latitudes are colder, but global warming actually may make life better in some places, right? May make the winters less harsh and summers more pleasant and so on and so forth. So that means you have to look at the patterns of warming, which means the change in the equator to pole temperature gradient is going to matter. That's what we talked about when we talked about atmospheric circulation. We talk about the Hadley cell and the mid-latitude eddies and so on. So you can see that under RCP 2.6 and 8.5, the polar amplification here is much more clear than here, but even here it's clear. So under global warming, you are going to decrease the equator to pole temperature gradient. You are not warming much here, but you are warming here, so you're going to decrease it. And here is our favorite warming hole, which is obviously in a place we talk about a lot in terms of deep water formation. There is lots of studies now trying to explain why this region fails to cool in the models, and there is evidence that even in the 20th century that region has not warmed so much. But you also see that there are patterns of warming. Some regions have more warming than other regions, but as I said before, the new models are better at producing regional scale warming, but still not perfect. It depends on what scale you want to look at. They're really good at global scale, but as you get to smaller and smaller regional scales, they have some problems. Okay, they are very good, but they have some problems. So nonetheless, you see that with RCP 8.5, which you can think of as business as usual, where we don't try to control global warming at all, like some countries did with COVID, where they said, forget it, we're not going to wear masks and we're not going to maintain social distance, we're just going to do whatever we want. You could do similar thing with climate action, and you can see that places like Sahara and Middle East would get really warm. Parts of the Himalayas and higher latitudes obviously would get very warm. Indian Ocean is warming already quite fast compared to the other oceans, and so on. So you can imagine that the Middle East will run out of oil at some point, but it'll get much warmer. It's already got many geopolitical problems with the Syrian war, the Israel-Palestine problem, Iran, Saudi Arabia. So you can imagine what this will happen. What will happen here if it keeps warming, and then you also begin to lose the income from the oil and so on. Okay, precipitation is much more challenging for models in general, even at weather time scale and at climate time scale of multiple seasons, because temperature has what are called large decorrelation scales. If you think about where you are and you think about temperature at your place and the place nearby, it's very likely that temperatures are very close to each other unless there is a front coming by. But it's possible that it's raining here but not there in a very close distance. So the temperature in general has larger scales than precipitation, which is like a popcorn that can pop up in small scales. So for models, precipitation is always a big problem, and you can see that there will be places which will get drier and there will be places which will get wetter, but the uncertainty in these things is large. For example, when you look at the 20th century, many models from the previous IPCC assessment released in 2014 did not do a good job of the Indian monsoon, as I will show in the next plot. This is the change in sea level. I will come back to this later. Again, global mean sea level is obviously rising, but nobody lives in a global mean sea level. So you have to see where sea level is rising. So you can see northeastern US is a hot spot because of the dynamics, and also because if Greenland glacier melts, the gravitational pull of the glacier will decrease and water will be released and pushed back against the coast. And it gets really bad here in RCP 8.5. 8.5. So you can see that RCP 8.5 here projects a very wet eastern Pacific, which means models are saying the global warming pattern will look like El Nino. Actually, they are not doing so well when you look at the 20th century. In the 20th century, especially since 1980, the warming in the East Pacific has been less rapid than the West, so the gradient has increased. So the ocean dynamic thermostat, global warming pause, and other things we talked about. Models are not doing so well, so can we really trust this projection from the models? So that's kind of difficult. Okay. This is the sea level rise. You can see that much worse sea level rise patterns in many places, and the island states in the West Pacific, in the Atlantic, and so on could be in deep trouble. Let me make this point in the next podcast because this is already long enough, and I want to make that point separately. So, models project with scenarios, and there are uncertainties at regional scale even for temperature, but for precipitation it's a bigger challenge. And precipitation is an important variable, and planning for the future of hydroelectric, agriculture, domestic water use, industrial water use, it's very challenging. So what people do is look at how things have changed over the past. Physical access to water and economic access to water, and quantity, quality, and access of water are critical issues. So lots of changes so far have been mostly about mismanagement. Country like India with very heavy rainfalls in coastal cities like Mumbai, for example, should not have water problems, and yet because of mismanagement sometimes they face water issues. Okay, that's something to remember. So human activities, human management combines with climate change, and climate acts as a multiple stressor or a stress multiplier. So human activity gets exacerbated by climate change impacts. Stop.